Okay, it's 1 o'clock Central Time again. Welcome to our next HDF clinic. I checked our Word document. I didn't see any questions there, but as we always do, I'm going to pause here and ask if anyone attending has a question regarding HDF, anything HDF that they would like to ask right now or later. I mean, we will take a few more breaks like this to see if there are any questions. Are there any questions? No? Okay, then I'll just sort of press on with our usual routine here. Last week's highlights, first up announcements. Again, a reminder, the deadline for presentation abstracts for the 2021 HDF user group meeting is still out there. You have about 2 weeks left if you would like to submit an abstract, and I encourage you to submit an abstract for the event that's going to take place mid-October. It was a big success last year, and I hope it's going to be an even bigger success this year. The other announcement is that there is a release candidate available for HDF 5.1.12.1, and I linked the announcement here, but if you go to the forum, you find it there. You will see the release notes. There are some download links, and so please, you can help by just trying to build it on your platform, running make test or something like that to see if there are any issues. That always helps. Before I switch to the forum, any questions at this point? Any questions regarding HDF 5? No? Okay, good. Then highlights from the forum. The first one was just, again, another reminder that there is one thread on the forum where we would like to collect sort of, call it a wish list of little improvements that you would like to see in the library with tools where you say, well, yeah, having this capability or this change would simplify my workflow dramatically. And we want to collect them and then discuss them at this HDF users group event, and then see what we can do about it. But so I encourage you to look at the issues that are there already, and but then also, yeah, contribute your own should you have one. There's another interesting thread going on regarding file locking, and that's actually the topic of our tips and tricks and insights. So we'll come back to that in a moment. It appears that it might be related to NFS, and yeah, that's sort of something we have seen in the past. It seems to be not related. It seems not to be related to sort of the swimmer flags and so forth, as we suspected initially. But then, yeah, we'll keep an eye on that. But I will, if there's time, talk today a little bit about what kind of file locking occurs in the library, and when and what and how and so forth, so that you have a general idea. And then there was an interesting other topic. A user was asking, he or she wanted to know, to determine when using compression, what is really the size of a compressed chunk in a file. And my colleague Alexander actually posted a little example in Python using H5Py, how you can obtain that information. And it's basically the get storage size method. And then, yeah, you can basically calculate the ratio between the theoretical footprint of that data set compared to the actual storage space occupied, and then that gives you the compression ratio. So that's a nice little example. And yeah, and there is obviously the underlying Python method called the C function, and so in the C API, there are plenty of functions to sort of to look at individual chunks and iterate over them, blah blah blah. And yeah, but that was a nice touch. Before I sort of jump into file locking, here's another chance if you have any question regarding HDF5, your applications, the use of tools, anything. The floor is yours if you would like to ask a question.
Gerd, is it okay to ask? This is Marta. Hi. I recently, it's not eventually a question that needs to be answered now. It's potentially a request for a presentation. I recently found out that someone at Argonne is working on a tool called Cachewall that I think is part of the developments that are being done for the exascale computing project under the ECP.
Can you spell how is that?
Cachewall. I can.
Okay.
Yes.
Yeah.
I can post the link. So I'm trying to particularly be more interested in all tools or libraries that are allowing me to use better the non-local storage, like for example the SSDs on Theta. And I was wondering, I know it's related with HDF5, so he is working to get that implemented with HDF5. You have to build it. So I was wondering if maybe for the audience will be useful from your point of view to talk about this tool. Let me post it in the chat. But again, it doesn't have to be today. It just, I thought about that in case.
Yeah. That's a great question. I mean, I'm familiar in general with the Cachewall. I have not used it myself, but I'd be happy to catch up on it, what the status is there and so forth. And yes, definitely one of the goals is to use sort of on an HPC system like local NVMe attached SSDs and things like that. And again, I'll find out when I look into the Cachewall if you can actually use burst buffers from the Cachewall as well. But yeah, definitely I'd be happy to look into that and report back next time.
It doesn't have to be exactly next time. I mean, whenever you think is appropriate, but it will be useful to, especially if you are submitting a new or you are releasing a new version, if that helps or something.
Yeah.
Thank you.
Yeah. In a similar vein, I don't know if you had a chance to probably by now a month or two ago, we had a webinar. We have another project with IIT called Hermes, and we had a webinar on Hermes, and there's actually a second webinar coming. We just had to postpone the originally scheduled second webinar, but it's coming. And I will include the link to Hermes, to the video, and also to the GitHub repository. The goal of Hermes is really to be a distributed buffering system that supports the sort of the storage hierarchy, which means that RAM, but also your NVMe SSDs, burst buffer, parallel file system, and other storage layers or storage tiers that you might have available without, similar to the Cachewall. I mean, the beauty of the Cachewall is really, once you've loaded the Cachewall, so to speak, you just treat your HDF5 file like an HDF5 file, and you don't have to worry about the storage hierarchy and all these other things. And similarly with Hermes, you don't really have to worry about, is there NVMe or are there SSDs, and you don't have to program it directly in the sense that you don't need to think about mount points and request them. And after this meeting, I'll just add a link. If you look on our YouTube channel, the first webinar gave sort of a conceptual intro into Hermes, but then yeah, stay tuned. There's going to be a second webinar sooner or later where we'll show actually some results in terms of performance and sample applications and so forth. But yeah, that's definitely a good topic and a hot topic, in the sense that yeah, it's otherwise for users way too complicated. People have to know too much about those systems, and it's different on every system. And people can constantly sort of change their code and have one code for this system and another code for another system. We need sort of better abstractions, and yeah, we'll definitely come back to that. Thanks for bringing that up. Any other question at this point? Okay, then maybe I'll go a little bit into file locking here. And this is actually based on a few notes that my colleague Dana Robinson put together a while ago about what kind of file locking we do in the HDF5 library and how we do it and so forth, just to clear that up a little bit. And I tried to structure it. So these are Dana's original notes. I just reorganized them a little bit in terms of an outline, quickly giving you an overview. Then as far as the library architecture is concerned, where certain things happen, how this relates to Swimmer, and then at least when locking was introduced, there was a little bit of a disconnect or a distinction between Unix, Linux, or non-Windows system, if you want, and Windows. There was no support for file locking under Windows at all. And then there's actually very topical. I'm glad I actually looked at the 1.12.1 release notes before coming to this meeting, because there are actually a few changes or improvements, I would say, regarding file locking coming in 1.12.1. Okay, file locking. The basic file locking algorithm implemented in the library is actually very simple. And when I say in the library at the moment, that means for 110x, where x is greater than 5, and 1.12 releases. There is no file locking in the 1.8 family of releases. So this is really only for 110x and 112x at this point, and of course develop. So the first thing to keep in mind, sometimes people make a connection between Swimmer and file locking, and although there is an interaction between the two, file locking always happens. Whether there's Swimmer or not Swimmer, it's just what happens precisely is a little different when there is Swimmer, but file locking happens. So if you open a file, no Swimmer, you just open a file, read, write, or read, and there is a slight distinction between the two about the kind of lock that the library will acquire. But the library will lock that file, and Swimmer or not. It's just if Swimmer single writer, multiple reader mode is intended or enabled, then on the writer side, the lock that we will see in a moment is removed after the super block of that file has been flushed, and all other, so the reading processes, they hang on to that lock until the file is closed. And so that's pretty much it. So at a high level on a Unix, but as of 1.12.1, as we will see based on the latest release notes, there's always locking involved. Unless, and we'll come to that in a moment, you disable it by disabling when you compile disabling file locking when you compile the library, or there are also environment variables through which you can control the locking behavior. So there are several mechanisms, and there is actually a file access property list as of 1.12.1, I believe, where you can control the behavior as well. But there is file locking in the background, Swimmer or not, it's just Swimmer is a little special. Okay, the architecture is that file locking really begins at the virtual object layer level. It may sound like file locking, so file, so one might think, well, this deep down in the VFD layer and so forth. And the answer is, well, in terms of the nuts and bolts, yes, some of that, but it really begins at the virtual object layer. But then not all wall connectors. So for example, the cache wall that you just brought up, off the top of my head, I have to be honest, I don't know if that would attempt to do any locking. But certainly with the thing that we call the native wall, which is sort of the thing that deals with things that we recognize in storage as HDF5 files, that certainly does locking. And then the actual lock operations are implemented at the virtual file level. So in the case of POSIX, for example, using the flock or the fcontrol, fcntl type calls. And actually, I forgot to highlight this. But for obvious reasons, since you will have multiple writers potentially on a single file, in the case of MPI-IO, there is no file locking for that virtual file driver. But for everything else, it begins, if you wish, at the wall layer, and then sort of the actual calls to the operating system specific or runtime specific lock calls happen at the virtual file layer level. Now, Swimmer, we said that there's something special about Swimmer, and what's special about Swimmer is that when Swimmer was introduced, that was introduced in HDF 1.10.0, and one of the file format extensions that was sort of introduced around that time was a so-called file consistency flag. And the purpose of that file consistency flag was really to indicate to the HDF5 library, to tools, whether a file was sort of opened in Swimmer mode and being written to in Swimmer mode, and or if that flag that was sort of placed among these file consistency flags, which was actually cleared after the application shut down. So just to make sure that if a proper shutdown had not occurred, then this flag would have been set in the file consistency flags, and then sort of any subsequent application or tool that would try to open that file would have detected, okay, there is an HDF5 file here that was not somehow properly closed because the application crashed or who knows what happened. And that just by default will block the HDF5 library or tools from proceeding, at least I think both actually. It doesn't matter if you open the file read only or read write, this file consistency flag, this particular bit that's set, will signal to the library and say, well, the user better knows about this, that there might be potentially something fishy about this file. And then there is an explicit tool that's mentioned down here and sometimes mentioned in the forum. There is a tool where if you are confident to say, yeah, I know that maybe this whole thing didn't shut down cleanly, but I know everything was written and I did sync and everything, so I'm pretty confident that this file is good, then you can use this H5 clear tool to actually clear this bit in the file consistency flag, and after that everything should be fine. So the library will just see there is a clear file consistency flag, and it will just proceed reading and writing, whatever you want to do. Now, so this is something about Swimmer, but so in the past, and so this is sort of written before I looked at the 1.12.1 release notes. In the past, file locking was only supported in Unix, Linux type or non-Windows type systems, because under Windows, the POSIX emulation, so to speak, under Windows did not support neither flock nor fcontrol. And so file locking occurred only under Unix/Linux. And there was this environment variable, and there is this environment variable called HDF5 use file locking that you can use to override the behavior of the library. So you can set that to false if you don't want any file locking to occur, or, and this is something that is new in 1.12.1, I believe, is this best effort setting, where if this best effort setting is not set and neither flock nor fcontrol are available, then the library will actually fail. It will just fail. It will say locking wasn't enabled, locking wasn't disabled. I wasn't told that this is supposed to be a best effort, so the library will just say, I'm confused, and will just fail. But as of 1.12.1, you can actually say, instead of true or false, you can say best effort. And then if the library discovers that neither flock nor fcontrol are available, but you said make this a best effort, then the library will just continue, and it will just say, okay, I tried my best to find something to acquire some locks here, but I wasn't successful. But then the user told me that this is a best effort, so I will just continue and not treat this as an error. Okay, so and as these things go, in the case of flock, for example, there are different types of locks. There are exclusive locks, there are shared locks, and there are non-blocking locks. So in the case of read-write permissions, or write permissions in particular, the library will acquire an exclusive lock on that file. And in the case of read-only, it will acquire a shared lock. And in both cases, it will OR. So these are like these typical enum things where you can OR this with other settings. So it will be non-blocking, so that other processes who run into that, the flock call will actually return immediately rather than blocking. And so then you can examine, you should do that anyway, examine the return code of the lock call to see that then the library, this other process will tell you, for example, oh, there was a lock by another process already. So not passing that, not checking that return code would be a mistake, because usually if you don't check the return code and you say, oh, that call returned immediately, you might think you got the lock, but you didn't really get it. It's only that you didn't check the status code. And so that's what can happen. Under Windows, as I said, since the POSIX layer did not support flock or fcontrol, it did not support file locking at all. And in the past, we thought about maybe at some point writing a Windows-specific virtual file driver that, rather than using the POSIX emulation layer, use the Win32 API, where you have calls like create file and sort of Win32 native locks. But that, I mean, there have been some experimental, some proofs of concept that this can be done and this can be done, but there's a difference between creating sort of a prototype and sort of taking this to production level. And so that didn't go anywhere. But as of 1.12.1, in the release notes, so 1.12.1 is again this release candidate that's available right now, and the release, I think, is more or less imminent. So it's mid-June. I'd be surprised if it's not out sometime in July. In 1.12.1, file locks will work on Windows. To be honest, I cannot tell you which locking calls we are using there specifically, but as the release notes say, they are available under Windows. So that closes this gap between Unix and non-Unix operating systems, so to speak. And there is this best effort value when it comes to use of file locking. Again, at least on the Unix, I don't know if Windows now with locking enabled behaves the same way. If the library is unable to lock, and then it will fail. However, if this best effort environment, if that use file locking variable is set to best effort, then it will just not it will just not fail. It will just continue and say, I tried my best to do the locking, but I couldn't really make any headway, but the user told me best effort, and I will just continue. And then as Dana said earlier, on systems like Lustre, so some of the parallel file systems, this might be helpful. And then there are these two new calls to set file access property lists. So there is an H5P set file locking and H5P get file locking API to either set what you would like the application, how you would like the application to behave, or to check on what the current configured library behavior is. And then, yeah, there is, if you are using auto tools, for example, depending on if you are using auto tools or CMake, you want to build the library with a specific locking behavior out of the box. So with locking enabled or with locking disabled or best effort, you have control over that now. So what was said here, we were talking about Windows, that reflects pre-1.12.1 behavior, but then as of a week ago, and with the release of 1.12.1, this behavior changes. So that gap between Unix/Linux and Windows will close. So there will be default locking behavior definitely for 1.12.1 going forward. To be honest, if you ask me, well, we have 1.10.7 right now. It's definitely not in 1.10.7. Will it come to 1.10.8? I will ask. I can report back next time. I just can't say. I don't know what the maintenance team what they think, if they're going to bring this to 1.10.8, or if this is something that's only in 1.12 going forward, and then 1.14 and so forth. So I'll make a note and ask and report back next time. So then I had a bit of a summary. So just to, this is a lot of detail, and maybe it's better to, once we've posted these, you can just go back and read these notes for yourself. But long story short, file locking, unless it's explicitly disabled by build option, by environment variable, or as part of your file access property list, file locking is happening always. As of 1.12.1, it is happening on Unix and Windows, or Unix and non-Unix. Pre-1.12.1, it was happening only on Unix/Linux, not on Windows. And if you are using 1.8, a 1.8 type release, then there is no file locking at all. Windows or non-Windows, doesn't matter. So that's kind of the high-level gist. And yeah, And then, of course, if you go back to that forum post, it appears that with NFS and sort of network file based storage, that there are some extra issues, how they handle locking and so forth. And yeah, unfortunately, I think there is no, it's not being tested or supported in any shape or form. So that's just trouble. And in those cases, what you can do is you can disable locking. I think that's the most straightforward thing to do. You can disable locking through the environment variable or when you build the library. Of course, you then have to be extra careful with how and when you access your files and so forth. But it's really NFS is not straightforward, at least from the HDF5 perspective. Anyway, looks like we are out of time again, but there's a next time. So I will definitely follow up on the cache wall, and I will find out what the plans are regarding file locking with 110.8, if we'll bring that in from 112.1. I would expect that we do, but then who am I? There could be technical reasons why we wouldn't do it, but then yeah, I'll find out and report back. And thanks for coming, and I'll see you next time.